Okay, today we went over net ionic equation. If you've ever been paid before, you know that net means like after taxes and after all the insurances, etc., have been taken out of your paycheck. Well, that's what we mean with double replacement reactions, like what actually is being precipitated out of solution. So let's back up for a second. Let's talk about reactions. Remember, we have a reactant and then a product, okay? And remember, we have a double replacement reaction is two compounds on both sides of the reactant, both sides of the arrow, and we use the circle method, so AB plus CD. A will join with D and C will come with B. So we'll get AD plus CB. We write the words first and then we write the formulas. So all of the balanced equations for net ionics will be double replacement reactions. The symbols we use are solids, liquids, gases, or aqueous. Remember, an aqueous solution is something that is a solid or something that is dissolved in water. In these reactions, some ions are called spectator ions. These are the ions that are aqueous on both sides of the equation. So these guys are soluble on both sides of the equations. The ions that are aqueous on the reactant side, but solid, liquid, or gas on the product side are called participant ions. I like to say the participant ions are the precipitate ions. They precipitate out. That's a tongue twister. That helps me remember. The participant ions are the precipitants. So to write the net ionic equations, we're going to write the balanced double replacement reactions, including symbols. We're going to use the solubility table to determine what precipitates liquid or gas, but we have on the back of your notes, you'll see the solubility of common ionic compounds in water. Now, not to panic, I am not going to make you memorize this. So soluble, we'll use the AQ. Exceptions, of course, will be a solid because these guys will precipitate out. So when you look at this, I don't want you to say, okay, here are these things. I want you to actually pay attention to these, like nitrates. Think about, what is a nitrate used for? Notice it's always soluble. It's always aqueous, and that's why it can permeate our membranes. That's why it's used in medications as food preservatives. It's used as fertilizers, etc. Here are sulfates. It's always soluble except when it's with strontium, barium, or alkali earth metals, or lead 2 or mercury. Here are insoluble compounds, so these guys are always soluble except when they're bound with ammonium, which is always soluble. And please note that it is also our only positive compound that we're working with, so all of these guys are anions. So all of these guys are soluble unless they're bound with ammonium or an alkali metal cation. Remember, these are lithium, sodium, potassium, rubidium, cesium, or francium. So phosphates, chromates, dichromates, hydroxides, carbonates, carbonate, that's why it makes such a good calcium carbonate, is precipitates out. We'll use that in a lab. Chalk. So anyway, so let's pay attention to what we're looking at and how it deals with solubility. Okay? So we'll use that chart to determine the solubility table to determine the precipitant. Then we'll circle the product of any which contain the participant ions. Then we'll write that net ionic equation with just the participant ions. If all of the spectator ions, if all our ions are spectator ions, then we write NVRXN, and that stands for no visible reaction. Okay. Let me go back up here and talk about one more thing about the participant ions. The participant ions cannot cancel. When we talk about cancel them out. All right? If they're soluble, we use AQ, and if they're insoluble, we're going to use S for solid. Okay? So let's practice. Cesium chromate. Just remember to use the circle method. Cesium is going to bond with chloride. Iron 3 will come back and bond with chromate. So we'll have cesium chloride plus iron 3 chromate. Okay, so here's our double replacement formula or equation. Cesium is a +1, chromate a -2, iron a +3, chloride a -1. Go ahead and write that charge number up there above the words, so when you're writing this out, you can write out your formula much easier. So CS2, CrO4, plus, I wrote that too close because we need to leave room for our state of matter. Plus FeCl3, and then our state of matter. Goodness gracious, you can tell it's the end of the day. Yields CsCl plus Fe2 CrO4 3, and what state of matter? Goodness. Okay, so we'll flip over and look at the chart. Okay, and we will see that chromate is always insoluble unless it's with ammonium or an alkali metal cation. Okay, and so on our first, it's with cesium, which is an alkali metal cation, so it will be aqueous, AQ. Then chlorine, we underline our anion because all of them are anions except for ammonium. So here's chlorine, and it's always aqueous unless it's with silver, lead, 2, or mercury. So this is aqueous. And then chlorine is always aqueous unless it's with silver, lead, 2, or mercury. So AQ. And then chromate is always solid, is a precipitant, unless it's with one of the alkali metal cations or ammonium, which it is not. So this will be a solid. Okay. Give you time to digest that. Go ahead and hit pause if you need to. So it tells me to circle the product of any, I got to balance this equation. So let me balance this equation. I have 3 chromates, so I have 3 chromates. 6 cesiums, 6 cesiums, 6 chlorines, 6 chlorines, 2 irons, and 2 irons. Okay? Circle the product of any which contain the participant ions. Remember, the participant ions are the ones that precipitate out. So let's circle these guys, okay? I'm going to go ahead and highlight just so we can see. I'll highlight in yellow. So let's cross out anything that is not circled. So cesium's not circled, so we'll cross that out. Chromate is circled, so we'll leave that. Iron is circled, so we'll leave that. Chlorine is not circled. Cesium and chlorine are not circled. Okay? So, Our net ionic equation is we have 3 chromates, and because it's no longer with cesium, it's going to have a -2 charge, and it is in a state of matter of aqueous, plus 2 irons, and that iron is in a +3 oxidation number, and it's aqueous, and it yields Fe2CrO4 3 solid. Take you a second to digest that. Pause the video if you need to. I'm going to go ahead and get started on the next one so this video is not too long. Aluminum chloride plus lead nitrate. Remember, use the circle method. So we'll have aluminum nitrate plus lead 2 chloride. Plus 3 minus 1 plus 2 minus 1 plus 3 minus 1 plus 2 minus 1. So we have AlCl3, state of matter, plus PbNO3 2, its state of matter, yields AlNO3 3, its state of matter, plus PbCl2 and its state of matter. Okay, so let's balance first, because of course we should always balance. I didn't do that the last time, but we should always do that. So we have a 3 and a 2, so I need a 3 and a 2. That gave me 3 leads, so I need 3 leads. 6 chlorines, so I need 6 chlorines, 2 aluminums, and 2 aluminums. So using my chart on the other side. Alright, let's start with chlorine, but just because it came first, I have chlorine here. Chlorine is always soluble unless it is bound with silver, lead, 2, or mercury. It is not, so it is aqueous. Nitrate, we already discussed that. Nitrate is always soluble with no exceptions. Again, we can put aqueous because we just said nitrate is always soluble with no exceptions. And then chlorine is always soluble unless it's with lead 2, so it will be my precipitant. Okay, so we'll circle that one, and I'll go ahead and highlight it because I did that the last time. Those are my participant ions that precipitated. Alright, so what? Lead, so that's not aluminum, but it is chlorine. It is lead, but not nitrate, and not aluminum, and not nitrate. So my net ionic equation here is this time 2 times 3 is 6 chlorines. Each one has a -1 charge. So aqueous plus 3 leads. So 3 leads. Each lead had a +2 charge, and they're aqueous. And they yields 3 PbCl2 lead 2 chlorides that are solid. Okay, so I'd like you to try the next one on the back, but please remember to write the formula first, so that way you don't end up doing a hydrohydroxide, because it should be water plus magnesium bromide.